Hello and welcome to Chapter 2, Section 1. This section is on translations. A translation is a slide where all points of a figure move the same distance in the same direction. So your shape doesn't get bigger or smaller, and it doesn't squeeze or get larger in any portions. So if you move triangle ABC to a new spot, triangle A prime, B prime, C prime, the question is, will line A prime equal line B prime equal line C prime? And will they be parallel? So we're going to look at moving an entire set of points. And we're moving it along a vector. And a vector is a quantity that has both direction and magnitude. So it has an initial point and a terminal point. So a translation along a vector means that the segment joining a point and its image has the same length as its vector, and it's parallel to the vector. So the answer to these questions are all going to be yes. So let's actually try it on some graph paper. So in Explore, on the first page of 2-1, while we're still discovering these, we have triangle ABC, and our vector is up to and over 6. So this has both a direction and a specific length, a magnitude. And our vector looks like this because we're going to go up to and we're going to go over 6. And our vector is going to be labeled with a V and an arrow. So this is our vector. So every point that we have to move up to and over 6. Up to and over 6. And this is C prime, and this is A prime. Now when we connect these dots, we have the exact same shape in the exact same size. And when we connect lines from A to A prime, from B to B prime, from C to C prime, we know that these lines are all the same length and that they are all parallel. This is the sign for parallel, so you don't have to write out the word. So as you look through the reflection questions, numbers 1 and 2, you can see that this just answered both of those questions. So go ahead and take a minute to read through those quickly so that it makes sense to you. So we just did example 1 that's actually under explain 1, and we did A together. And I'm asking you now to try example 1B and answer question 3. Pause here, give that a shot, come back when you're done. So in example B, 1B, we have a vector that goes back 3 and up 5. Back 3 and up 5. Back 3 and up 5. So we're going to take our ABCD, what is this called? Trapezoid, and we're going to translate it back 3 and up 5 for each point. And when we make trapezoid ABCD prime, it ends up being the same shape and the same size. When we connect A to A prime, B to B prime, all of those lines are the same length and they are all parallel. And if it doesn't look like it because some of these lines are a little crooked next to each other, try folding your paper to see if it's true. And in question number 3, the way that they're the same is that the steps are the same, But the way they're different is that a translation tells you where to draw it. When we're drawing translations on a coordinate plane, like it mentions in Explain 2, it gives you a set of points for their image, but it actually describes a vector in terms of change of x and change in y. So in this instance, it's going to ask you to add 4 to every x and to add 6 to every y. And that will give you a change in x and a change in y. So our vector will look like this, but this is the way they can write it when they're giving coordinate plane combinations. And you can see on the bottom of example 2a how they use this vector to change this pre-image to a new image, ABC prime. What it's asking you to do is create a table of all of these, and using the vector, identify the 3 new points. So if you will turn the page, in example B, they've given us 3 points, and they've told us that our vector is -2, +3. And what they're asking us to do is give them the new points. So x -2 is 1, and y + 3 is 3. X -2, y + 3. X -2, y + 3. And we go from having an image here to an image that's moved here. 2 backwards and 3 up. So take a minute, pause here, and try your turn, numbers 5 and 6, to do this same kind of translation. In number 5, our ABC triangle has moved to this position in quadrant 2, ABC prime. And in problem 6, our PQR triangle here in quadrant 4 has moved to PQR prime in quadrant 3. Please let me know if you have any questions or problems with any of this. The last thing this section is going to ask us to do is, if we're given the coordinates of a shape and a shape prime, its image, can we find the vector? And essentially what we need to do is, for each point, we're going to count the change in x and the change in y. So as we can see in example 3, section A, under explain 3, it gives us triangle ABC and its image, and we're going to count from 1A to the next that we go 5 to the right and 4 down. So that's a movement vector of 5, -4. Can you find the vector for example B? Pause here and come back when you're done. For example B, we move from 2 to -3, which gives us 5, and 4 to -1, which gives us 3. So our vector is 5, 3. Please take a moment to answer questions 7 and 8 and come back when you're done. For number 7, for the horizontal, y = 0, so there's no change in height. And for number 8, x and y are opposite, which means each of them are negative. So now you have elaborate questions. Since we're nearing the end of this section, please answer numbers 9 through 12 and come back when you're done. Number 9 is the same distance, but the opposite direction. Number 10 is 6, -8. x minus 2 equals 4, and y plus 7 is negative 1. Number 11, the x is negative because it's to the left, and the y is negative because it's going down. And number 12, you used to slide it over and up or down. Now you slide it parallel to a given vector. So there's the x and the y movement versus along a vector direction and magnitude. So it's really just a matter of semantics. Your homework for this section starts on my page 69. Oh, I can't even say that anymore. You're going to do numbers 1 through 21 all. Please let me know if you have any questions, and I will see you next time.